try and hold this so I can keep my slides to help prompt me. So I guess I'll just kind of launch into it. So my name's Melanie Kirby, and I'm a second-year master's student at Washington State University. So I'm going to talk. Oh, okay. I'm a second-year master's student at Washington State University, and so I'm going to share some information with you all today about WSU Bee Lab's efforts to help farmers and beekeepers and ranchers and gardeners from here to beyond, as we like to tell folks. Dr. Shepard is actually very keen on applied research, so to him it's not effective unless it actually is pertinent and helpful to people whose industry and livelihoods depend on it. So as many of you know, there's a large diversity of bees. North America alone, we have over 4,000 species. And the Honeybee Lab in particular, of course, focuses on honeybees. So I'm going to talk a little bit about that research, but you've got bumblebees, alkaline bees, you've also got mason bees or carpenter bees. And then in the middle shot there is actually melipona, which are stingless bees, which we don't have here in North America, but they're quite cute. They're very small, and they're in tropical climates. To just share a little bit of history about honeybees and sort of the breeding efforts that I'll talk about shortly. Honeybees were brought over from Europe and Asia back when the Pilgrims came. And then with the advent of steamboats, they were able to bring more over, but then they started replicating themselves. And so we don't really import them that much. We also had a disease that came about in the 1920s, and that really put a curb on importations. It was called the Isle of Wight disease, which was from Europe, from England actually. It was tracheal mites. So since the 20s, that has put a ban into effect, and so we're not actually able to import any honeybee stock into the Americas anymore. Because of that, and because of large-scale production, it's kind of become marginalized, at least within the production industry of bees and queens. And American bees, to a certain extent, have become inbred. And so that has its own set of problems. And then you add on top of that pesticide issues and pests and pathogens, which I'll talk about shortly. So all of this has led to them beginning what they call a germplasm repository program. So Dr. Shepard and Dr. Hopkins, who are featured here, also Sue Colby, who lives on Whidbey Island, they traveled to Europe to actually collect semen, because they're not allowed to bring back bees, and then through insemination they're able to kind of reconstitute these genetics and then open mate them and then share them with producers. And it's their efforts to bring in stock that's already acclimated to various pests and pathogens and be able to share that. So I kind of equate that to being a seed saver of sorts, if that makes a little bit better sense, except it's with insects. So you're trying to find insects, or bees in particular, that have already adapted to a variety of circumstances, and then bring those seeds back and then be able to share them with producers near and far to help them sort of broaden that genetic pool as well. So these are a few shots of them actually in the process of collecting drones, and then we have mating nukes up there in the top center. Then those go to producers. The producers actually now have become unified to an extent, and we have a national germplasm repository program now that's underground in Fort Collins, Colorado. So kind of like that cool big seed bank that's in Norway. Now we have one in the U.S. For bees, and it's actually housed next to cattle and other poultry and heritage breeds that they preserve. This shot here is actually some additional research that's taking place not only in Washington but also in Idaho and California with cold storage for bees, using mycelium for varroa control, which is a mite that's a big pest, and then also looking at tinctures with mushrooms and working with Paul Stamets for bee health. This is a shot here in the middle is Megan Ash. She actually just graduated with her master's last year and is now in the ZAC lab working with wasps, and because they can be so predacious and affect a lot of different critters. And so she looked at pollination behavior, and now with technology we kind of have the modern tools to really observe and evaluate and quantify. I'm actually a farmer at heart. I'm a beekeeper by trade, so I'm 20 years out of school, so coming back to school has been a really interesting transition, but my research has kind of built off of hers. And so these are pictures of what I'm working on, which is actually looking at queen mating behavior. We don't know between the different strains and races of bees which ones get out to mate first, which ones are better suited for rearing early in the season if we have volatile spring weather. So I'm collaborating with some WSU engineering undergrad students who've designed a little RFID reader unit that's radio frequency identification. It's passive, like a little sticker, and it goes on the queen's back, and then I'm able to monitor when she leaves to go mate and how long it takes and when she comes back. And so we're able to kind of really quantify now what beekeepers have been seeing in the field for a while, which strains actually perform better earlier in the season. So rain or shine, we're always working. That's kind of the shot there in the your upper left, I guess. And Nick Nager is the doctor in the middle who's doing the work on the mushroom tinctures. We do sampling at our diagnostics lab, and Erin O'Rourke will be here this afternoon. We have a little table corner out here, and so she can talk to you about that. But we also do classes and also plant more flowers. It's all about habitat. Thank you.